Let's make up a new pronumeral and we'll call it A. And let's say that A is counting the number of apples in a box. Number of apples. So here's our box of apples. And the number of apples in the box might change. We're not sure yet. Let's now make a term using our variable A. So let's say we have 2A as a term. And remember from earlier, we've learnt that a number in front of a pronumeral, it's called a coefficient, but it means multiply by. So 2A is the same as 2 times A. Or in other words, 2 times the number of apples in a box. And if we had 4A, that's the same as 4 times A. But what if we have an expression that has 2 different terms in it, like 2A, and then we're adding that to 3A? What can we do here? Well, we know that 2A, that just means 2 times the number of apples, and 3A means 3 times the number of apples. So we can actually combine these two together because they're both counting the number of apples, and we call that like terms. Like terms have the same pronumerals. So if we have 2 lots, 2 times the number of apples plus 3 times the number of apples, that's the same as counting 5 times the number of apples. So we can picture it's like having 5 lots of that box of apples. Five times however many apples are in that box. So whenever we see expressions with the same pronumerals, we can combine the like terms together. And this is called grouping the like terms, or simplifying. Because we're making fewer terms than we started with. So let's look at another example that we can simplify. If we have 7 times t, which could be the number of trees, plus 2 times t, take away 3 times t. Well, 7 lots of t plus 2 lots of t, that's 9 times the number of trees, take away 3 groups, that simplifies to 6 times the number of trees, so 6t. The next example is a little bit harder. We have 7 times the number of apples times the number of trees plus 3b, and b could be the number of bananas, take away 2 times the number of trees times A, the number of apples, plus 4b, take away 5b. So with a long expression like this, it's best to think, what are the like terms here? So we have a term here, 3b, positive 3b, and positive 4b, and take away 5b. These are all involved with just the pronumeral b. So these are all like terms. We also have 7 times a times t, and take away 2 times t times a. And here, even though the pronumerals are swapped around, these are actually like terms still. Because remember, with multiplication, 2 times 3, which is 6, that's the same as 3 times 2. And that's called commutativity. So we can swap the numbers around and we still have the same answer. Which means we could rewrite this as 2at, negative 2at, which is definitely a like term with 7at. So now let's group all our like terms together. We've got 7at, take away 2at. That means we have 5 groups of a times t. And we have 3b's plus 4b's. That's 7 times b. But then we're taking away 5b's. So that's take away. That leaves us with positive 2b's left over. And now we've simplified. The last thing to look at is if there are squares involved or powers. So if we have an expression which is x squared plus 3x squared, these are like terms because they both have an x squared in them. So we have 1x squared here. We don't actually write the 1, but we have 1, and we're adding it to 3. So we have 4x squareds in total. But if we have an expression with 5a squared times t, and we're adding that to 5a squared, these aren't like terms because we don't have exactly the same pronumerals in each. So, not like terms. In another example, if we have 3 times x times y squared, and we're taking away 3 times x squared times y, these aren't like terms either. And we can see why by actually thinking about what they mean. So remember that there's a multiply symbol in here that we don't write. So 3xy squared, that's the same as 3 times x times y, and squared, remember, is times itself, so times y again. Take away 3 times x, and x squared means times x again, and times y. So looking at this in expanded form, we can see we have 2 y's multiplying in the first term, but in the second term we have 2 x's multiplying. So again, these are not like terms, so we can't group those.